Hi there, this is Mr. Franco. I am a teacher, and welcome to my channel, Sir Matigo. Today I am going to explain the proofs of the properties of parallelogram. So there are five properties. Number one, in a parallelogram, any two opposite sides are congruent. Okay, so we have this parallelogram here. It says that any two opposite sides, so we have these opposite sides, one pair of opposite sides, another pair of opposite sides. So there are two pairs of opposite sides. These opposite sides are congruent. So we begin by providing this given parallelogram care. And then we are going to prove that CA, okay, CA, this one, is congruent to ER, this one. And CE, this one, is congruent to AR, this one. Okay, so let's mark this. This one is congruent to this one, and this one is congruent to this one. Now, let's begin the proof. We have number one. Your first statement, parallelogram care. Your reason is given. The next statement. Now, since we have parallelogram care, we can say that CE is parallel to AR. That's according to the definition of parallelogram. Okay, and then draw EA. Okay, let's have this diagonal EA. Since we are proving that these two pairs are congruent, we want to make two congruent triangles. Okay, so by drawing this diagonal, we can have these two congruent triangles. Corresponding parts are congruent. We have EA as our diagonal, and our reason is line postulate. We can have this angle and this angle. Since our side CE is parallel to AR, this diagonal will now serve as a transversal. Okay, so it says that if two parallel lines are cut by a transversal like this, the alternate interior angles are congruent. So these are the alternate interior angles. The other is this angle and these angles. This angle are also alternate interior angles. So we can have this statement. Look at this. Angle CEA, this angle, is congruent to angle RAE, this angle. Okay, so we have this statement. And also, REA, this angle, this one, is congruent to CAE, this angle. This is it. Okay, our reason for this is we have alternate interior angles are congruent. That is AIAC. Okay, so let's go back to this figure. We already have two corresponding parts that are congruent. It says that in order to make two congruent triangles, we need to have three three corresponding parts that are congruent. So we need this diagonal. So we have EA is congruent to EA. That's EA is congruent to EA. This side is the side of this triangle, and this is also the side of this triangle. Our reason for this is reflexive property of congruence. This one. Okay. Now we already have three congruent corresponding parts. This alternate interior angles and this side. So look at this. We have angle, side, angle, angle, side, angle. So for this triangle, we have angle, side, angle. And for this triangle, we have angle, side, angle. So these two are congruent by A is a congruence postulate. So we say that triangle ACE is congruent to triangle ERA. This one. Okay. So our reason is A is a congruence postulate. Now, let's proceed. Since we already have two congruent triangles, okay, these two, we can now look at this. If these two triangles are already congruent, then we can say that their corresponding parts are also congruent. We can say that CA, this one, is congruent to ER, this one. And CE, this one, is congruent to AR, this one. So these are corresponding parts after making these two triangles congruent. Okay, so we write CA is congruent to ER, CE is congruent to AR, which is the proved part. And our reason, CPC, TC. That is, corresponding parts of congruent triangles are congruent. So we are able to prove that in a parallelogram, any two opposite sides are congruent. Okay, let's proceed to the second property. This is the second property of parallelogram. It says that, let's cover the other text, not to be disturbed. Okay. So we have this. In a parallelogram, any two opposite angles are congruent. So we have parallelogram care. Okay. It says that any two opposite angles, so we just have this. One pair of opposite angles, another pair of opposite angles. So we have two pairs. So any two opposite angles, okay, are congruent. So C is congruent to R, E is congruent to A. Okay, let's prove this. In parallelogram, we have given parallelogram care. We are going to prove that angle C, this one, is congruent to angle R. Okay. And then angle E, this one, is congruent to angle A. This one. Okay, so let's have the proof. Two-column proof. Look at this. The first is you have to present here. The first statement must be from the given. We have parallelogram care. Reason, it is given. So since this is a parallelogram, our beginning statement, therefore we say that CE is parallel to AR. CE is parallel to AR. Okay, so why are we doing this? We are trying to make congruent triangles again. The proof of this is just similar with number 1. Okay, so we have parallelogram, and then we have parallel sides. CE is parallel to AR. Definition of parallelogram. Next, let us draw EA. This EA. So CE is parallel to AR. Okay. So draw EA, which is line postulate. Now, we also notice that as we made this segment, we have angle CEA, this one. Okay, this angle is congruent to RAE, this angle. Okay, so these two are congruent. Another one, let's have REA, this angle, let's have this mark, and this is congruent to angle CAE, this one. Okay, so these are congruent and these are congruent. Right, so that is alternate interior angles are congruent. Okay, again, alternate interior angles are congruent. We can use this again as our statement. So we have EA is congruent to EA. We have angle, side, angle, angle, side, angle. So for this triangle, we have angle, side, angle. And for this triangle, we have angle, side, angle. So this is A is A, congruence postulate. Okay, we can say that triangle ACE, this one, ACE, this is the triangle, is congruent to ERA. So this is the triangle. So our reason is as a congruence postulate. Since these two triangles are congruent, we can say that angle C is congruent to angle R. Okay, angle C is congruent to angle R. That is by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so we prove that C is congruent to R. Now, we can also prove angle E is congruent to angle A by making another diagonal here. And I will give that to you as your job. You can have the same proofs. I mean reason. You can have the same reason. And your statements here will have different letters. Okay? So that's it. Now let's proceed to the proof of the third property of parallelogram. This one. Okay? The third property, I will cover this text to avoid disturbance. Okay. See it here. The third property says that in a parallelogram, consecutive angles are supplementary. This angle C is consecutive to angle A. Okay, these are consecutive angles. And it says that these angles are supplementary. So these are supplementary. In other words, these angles, the sum of these angles is 180 degrees. Okay, next, this angle and this angle are also supplementary. The sum of the angles is 180 degrees. This angle and this angle are supplementary. This angle and this angle, okay, this angle and this angle are supplementary. Okay, so we are going to prove that these are supplementary, these are supplementary, these are supplementary, these are supplementary. So we have in writing, given parallelogram care. We are going to prove that angle C and angle A are supplementary. This one. Okay. Angle A and angle R are supplementary. This one. Angle R and angle E are supplementary. This one. And angle E and angle C are supplementary. These angles. Okay. I am just going to show you the proof of the first consecutive angles. This one. Angle C and angle E are supplementary. Maybe these three would be your job, will be your exercises. The first one, first statement here, given parallelogram care. Okay, it is given. The second is, by the way, um, since we are proving the first consecutive angle, that is C and A. Okay, let us analyze. Now, here we have already a parallelogram, and then we have CE is parallel to AR. Okay, CE is parallel to AR. Now, angle C and angle E are supplementary is to be proven. Now, I am going to use this as parallel sides. In other words, this will be this will serve as the transversal. It says that if two lines, if there are lines here, if two parallel lines, okay, are cut by a transversal, interior angles of the same side are supplementary. These are supplementary angles. Okay? These are interior angles of the same side. Now, since these are supplementary and these opposite angles are congruent, these opposite angles are congruent. In other words, these are also supplementary. So we will be able to prove this. Okay, now let's have to continue our statements and reasoning. Okay, we have angle E. By the way, since CE is parallel to AR, this one, this is our transversal. Then we see that angle E and angle R are supplementary. This one. If two lines are cut by a transversal, interior angles of the same side are supplementary. Okay. Next, we have here for angle E, opposite to this is angle A. This one. And angle R, okay. And angle R, which is this one, opposite to it is angle C. Okay. We will reason from parallelogram property number 2. It says that opposite angles in a parallelogram are congruent. We can use that as our reason because it has been proven. Next is this one. Since these two angles are congruent, and these two angles are congruent, these are supplementary. Therefore, we can say that these angles, okay, angle C and angle A, are also supplementary. So therefore, we say angle C and angle A are supplementary. So the reason is, this is the reason. An angle that is supplementary to one of the two congruent angles is supplementary to the other also. Okay, so we are able to prove the first statement to be proven. Okay, we are done with this, and I think you can do this. This one, this one. Let's proceed to property number 4. Okay, the fourth property of parallelogram says that the diagonals of a parallelogram bisect each other. Okay, so we have this parallelogram here. We have the diagonals, two diagonals that bisect each other. In other words, when these two diagonals bisect, this one, this segment from here up to here is equal to the segment from here up to here. So in other words, this diagonal is divided into two equally. This diagonal is divided into two equally. So this one is equal to this part. Okay, we can now make a given. So we have parallelogram here with diagonals CR or segment CR is one, and segment EA, this one. We are going to prove that segment CR and EA, okay, this one, bisect each other. Okay, so look at this. We have this already. Okay, this diagonal is divided into two equally. So the definition of a bisector, these are equal and these are equal. Okay, so now let's go to the proof. Okay, so we have this. The first statement says that parallelogram here with diagonal CR and EA, that's given. And then since this is a parallelogram, by definition of parallelogram, we have CA is parallel to AR, this one. And then CA is parallel to ER, this one. Definition of parallelogram. Now, look at this. Using these parallel sides, CE is parallel to AR. We can have this as our transversal. If two parallel lines are cut by a transversal, we have these alternate interior angles are congruent. Okay, these angles are congruent. So we write ECR, this one, okay, angle ECR is congruent to angle ARC, this one. Okay, so this angle is congruent to this angle. And if we are going to use CA, is parallel to ER, okay, we can use this as a transversal. Okay, so EA is a transversal, therefore these are alternate interior angles. And so we write angle CEA, okay, is congruent to RAE. So these two are congruent, which is this one. Okay, now this is our reason. Alternate interior angles are congruent. Okay, alternate interior angles are congruent. Number 4, the fourth statement. By the way, in number 3, we already have two corresponding parts that are congruent. Again, in congruent triangles, we only need 3 corresponding parts. 3 congruent corresponding parts. So we already have 2. This one and this one. Okay. So look at this. Okay. Since we already have angle, and then you have angle, we have angle, and then we have angle. So we need only one corresponding parts. This one is congruent to this one by parallelogram property number 1. Okay, so we can say CE is congruent to AR. That's we write CE or segment CE is congruent to segment AR. So we already have 3. Okay, angle, side, angle, angle, side, angle. Okay, so we have the reason is parallelogram property number 1 for this. Okay, so we can conclude now that this triangle, okay, triangle ECO, this one, is congruent to triangle ARO, this one. So these two triangles are congruent by ASA congruence postulate. So we write triangle ECO is congruent to triangle ARO. The reason is ASA congruence postulate. Okay, now we can apply now the corresponding parts of these two congruent triangles. So we can say that CO, for this triangle, we have CO is congruent to RO for this triangle. And EO is congruent to AO. Okay? So there is marking here. This is equal to this. This is equal to this. Okay? So we write CO is congruent to RO. This one. And segment EO is congruent to AO. This one. CPCTC is our reason. Corresponding parts of congruent triangles are congruent. Because we already have here 2 congruent triangles. So this will become corresponding parts of congruent triangles. Okay? Now, look at this. Since this segment is divided equally, that is the illustration of the definition of a bisector. So CR and EA bisect each other. Reason, definition of bisector. So we are able to prove this. Okay? So we are able to prove that the diagonals of a parallelogram bisect each other. We have the last property to prove. And this is the easiest one. Okay? So the last property says that a diagonal of a parallelogram divides the parallelogram into 2 congruent triangles. Okay. So there are two congruent triangles because of this diagonal line or segment, a diagonal segment. So our given is parallelogram care with diagonal CR is 1. We are going to prove that triangle CER for this is congruent to triangle RAC. Okay, this one. So these two triangles are congruent. Now let's have the proof. Number 1, we have parallelogram care with diagonal CR or segment CR given. Now let's analyze this figure since we are just making two triangles congruent. So we can have this. Using property number 1, this will be congruent, this will be congruent. Okay. And using a reflexive property, this is equal to itself. So you can have side, side, side for this triangle. You can have side, side, side for this triangle. That's SSS. We are able to prove this. Now let's write it. So we have CE is parallel to AR. Okay. And CA is parallel to ER. Okay. It's 1. Definition of parallelogram. Next, CE is congruent to AR. Okay. CE is congruent to AR and CA is congruent to ER. Reason? Parallelogram property number 1. That will be our reason. Then, since you have this diagonal, CR is congruent to CR, our reason is reflexive property of congruence. Okay? Reflexive property of congruence. Therefore, we already have these 3. 1, 2, 3 corresponding congruent parts. Therefore, these two triangles are congruent by SSS congruence postulate. That's it. I hope you understand my explanation. I'm sure you will be able to answer your homework if you have in your studies. Thank you so much. Thank you for learning. Please don't forget to subscribe. Bye.